Alright, so this is section 3.5. We'll start right away. So this is called cross multiplication. Remember when we were learning dot product? It's going to be sort of like that, but it's going to be slightly different because how they multiply the matrix entries is a little different. So let's see how we play this one out. So we have these three vectors, and right now there's no specific preference. We're just practicing how to do cross product. So yeah, so there are a number of different ways to memorize this, but this is how I think the best way to memorize it. So basically when you do a cross product, right? So think of it this way. So you have u and v here as an example, right? So order matters. So look at the first vector that comes, which happens to be u, right? Listed on here, right? So u1, u2, u3. Make it like a mini matrix of your own, right? And then and the next vector is v, so all the components v1, v2, v3. So like that, right? So what I do is I draw a circle, like that, right? So it's going to be one circle going from u1, u2, v1, v2, and then another circle is going to go u2, u3, v2, v3. So it doesn't matter how you do it, but basically what needs to happen is you're going to do this circle first, and then the ones that don't overlap, u1, u3, v1, v3, and then you're going to have your first circle here. So see, u2, u3, v2, v3, that first circle is going to be your first component, vector component, net vector component, that's what I mean. And the second one is where there is no overlap, so it's going to be u1, u3, v1, v3, so it's going to go right here. And then that's going to be u1, u2, v1, v2, which is the first circle, goes right over there, right? So why is there negative here though? That's the weird part, isn't it? Well, if you remember when we were finding the determinants, right? So remember, if you use a sign chart, this is essentially the same thing as positive, negative, positive, negative, positive. Yeah, negative, right? So basically what happens is, yeah, so using the sign chart, so first one, positive. Second one, negative. Third one, positive. That's what it really means, but they don't tell you that. Basically all you have to know as far as we're concerned is put the negative in the middle, right? Do not forget that. So that's all there is to it. So be familiar with this. I don't care what method you want to use, just make sure you get these in the end, right? So bear that in mind. Let's keep going. A is going to be a vector v times w, a vector. So again, what I did was there's a v here, right? So v and w, that's what we're doing, right? So first one's got to be u2, u3, v2, v3, right? So I'm going to look at 2. I'm going to look at 2 and negative 3 and 6 and 7, right? So that's going to be 2, negative 3, 6 and 7. Perfect. The middle one, the outside one, right, where the overlap, everything except the overlap in the middle, right? So it's going to be 0, negative 3, 2, 7. 0, negative 3, 2, 7. Don't forget the minus sign, right? Cool. That's done. Next part is going to be the first circle, right? So u1, u2. So the first two and first two. So 0, 2, 2, 6. So I have all that fun, and these are all determinant expressions, right? And we all know how to do determinants, especially that are 2 by 2, right? Like this should be done deal, right? So A times D minus B times C. That's all there is. So for this one, I showed you how the numbers will play out, and that's going to be just 32, negative 6, negative 4. Yeah, not rocket science once you master these, right? Next one is interesting, and this tells you something. I'm doing exactly the same thing as A, but the order has changed. So it's now vector W times vector V, right? So nothing really changes as far as this is concerned. So you do the same thing. So so remember, matter, what comes first matter, right? So here U and V, so something that comes first must be on the top, right? So now I'm going to flip this for this guy, right? So essentially, either you could just flip here, or you could just, flip the whole thing. So basically W is going to come first. So 2, 3, 6, 7 goes here, and then the 2, negative 3 goes here. So all we're doing is changing we're changing the rows, right? So that's all there is. negative still stays the same. So if you do that, interesting. Same magnitude of numbers, but opposite signs. What does that tell you? It tells you that if you have, if you're, where did I put that expression? Yeah. So if you have some kind of a cross product, and then you just reverse all you did. If all you do is reverse the order, it's the same number except there's a negative in front. So that's actually one of the rules, right? Another interesting rule that will become handy if you are doing a cross product of itself, right? Always, always, always 0, right? So remember that, right? That will become really handy later on, right? So that's that. For C, it's just going to be u plus vector u plus v, and the cross product with w vector. So again, looks weird, but again, these are just additions, right? So you have the u and the v, just add them up. 3, 0 is 3, 2, 2 is 4, negative 1, negative 3 is negative 4. So, and then you're just doing the same thing as we've been doing before. So here are the numbers, and let's wrap up the rest of the question 1 component. Okay, so continuing on with question 1. So basically now we're going to have a dot product, right? So you have a v vector, dot product of v vector, and cross product of v and w, right? Interestingly though, why bother doing additional work? Because from part A, we already calculate vector cross product of v and w, right? Which happen to be this vector, right? So all we have to do is just to dot product of v and this whole expression. So I have v and I have the net net cross product of v and w right there. So do a dot product of that, 0 times 32. Well, all of us should be familiar with dot product by now, right? So that's gonna equal to, interestingly, 0. Okay, so what does that mean actually? Doesn't that mean this overall net vector, what am I saying? The net vector, which is the cross product of v and w, that expression is, that net vector is going to be perpendicular or orthogonal to vector v. So that's going to be useful later on, but that's essentially what it means, right? Because orthogonal definition of orthogonal relationship is if you do a dot product, it must equal to 0. So let's go to E. Now remember, I sort of pointed this out when we were working on C. Vector v, and you're doing the cross product, right? Don't waste your time. It's gonna be 0. Now the solution manual shows you that it will actually become 0. So if you can find that, that's great. But yeah, if you do as a rule for cross product, if the components are identical, so you're doing the v and v, the vw, whatever, right? As long as those two vectors are identical, right? It's gonna give you 0 vector. So, oh, by the way, be careful. I may have misspoke, but I won't know until I check the video again. But it's not 0. It's vector 0, right? So it's going to be 0, 0, 0. So remember, it's not going to be a number, right? It's not different from dot product. It's not going to be a number. Cross product will give you a vector. So, FYI, right? So F is the same thing. It looks like a complicated thing, but I don't really care what U minus 3W is, right? Because I'm doing cross product of this and the same thing. So if I cross product the same thing, it's always going to give me a 0 vector. Always, always, always. So knowing these rules can save you quite a nice amount of time during the quiz. I think most people figured out the quiz are pretty easy, but nonetheless, it's a useful characteristic that we should bear in mind, right? Question 7, basically they're asking, wait, what was the question asking? Let's see, there we go. Alright, found it. So yeah, so the question is saying, use a cross product to find a vector that is orthogonal to u and v. So I need to find the cross product. So these are the two vectors. We know how to do cross product by now, right? So So yeah, so again, I don't even have to draw it anymore, right? Because I know it's gonna be u2, 3, and then So it's going to be first two, then it's going to be the first and the last, and then it's going to be first and two. Because I remember that. First circle, anything that doesn't overlap, and then second circle, right? So 4, 2, and then 6, -6, 2, and then it's going to be -6, 4, and do the same thing with V, and you're going to get that, right? So here's the thing though, the question stops here, but I like to do this too, because, you know, technically speaking, we should prove that it's orthogonal, and the only way to prove if anything is orthogonal is if you do a dot product, right? So I found this, so I'm actually going to do dot product for U and V, because it says it's orthogonal to U and V. So I do that, and then it looks complicated, but if you add them up, it's going to be 0. Same thing here. So therefore, this is, so UW is orthogonal to U and V. So something like that would be very nice for your upcoming quiz. So that's question 7. Question 8 is essentially the same, so I wouldn't really bother with it. You know, but feel free to practice if you'd like. Actually, no, I'll do it just to be sure. So I'll do number 8, and then let's do it. Okay, so we're working on question 9 now. So basically now we're trying. So now the idea is to find the area of the parallelogram, and or you know, a triangle, depending on how you look at it. And we'll talk about both, right? FYI, interesting. See what it says here? Parallelepiped. So I wonder if such thing exists in chem lab. I know there's a pipette for, you know, titrations and stuff like that, but yeah, anyways, just, you know, I wish I get paid to edit these things. Granted, it's a relatively new edition, so I'm sure there were a lot of mistakes, but nonetheless. Okay, so getting distracted now. Let's go back to what it was. So basically what you need to know is that the norm of the cross product is going to equal to the norm of U and norm of V, and then sine 0, right? So as you know, we don't have to know about the proof yet. We may have to later on, but for now this is good enough, right? So basically all we're saying is this is the area of the parallelogram, right? So that means, so think of this as a base and this whole thing as the altitude. And there's a visual representation of what it look like. So parallelogram is going to look like that, and basically all we're looking for is area is sort of like, so imagine if it was like this, right? Of some sort, right? So it doesn't look pretty, I know, but basically this area is going to be U sine, which is, you know, it makes sense, right? Trig wise, this is the angle, so opposite of that is sine. So and then you do this, times it by the base, and then basically that should give you, that is exactly the area equation for the parallelogram, right? So that's the case. Now if it is a triangle though, because then it's effectively cutting in half, right? So that's why, you know, if it's a triangle, don't forget to divide by half, right? Base times height divided by 2, right? So that's all there you need to know about it. So let's go jump right into question 9. So we're given these two vectors that make up the parallelogram. So they're basically asking for area, right? So, you know, do the cross product, right? And then, you know, the same drill, you have that. And then remember, area is supposed to be the norm of that, right? So just find the norm of that. And norm should be pretty comfortable for us by now, right? So I get all the components, square them, and then square root the whole thing. 59. Done. So, easy stuff. Should I do question... should I bother with question 10? Maybe that's not necessary. We'll just jump right into question 11. Same thing, but they give us vertices, so points rather than vectors. But you can suspect what that's going to look like, right? It's sort of what we did before 3.3 with the orthogonal unit. Remember, there are two vertices or points, and then we just have to find the vector of each, and then just test the orthogonal nature. We're going to do something similar, I'd imagine. So, on to question 11. Okay, so on to question 11. So we have four vertices, or the points specifically. And basically, but you're just finding the area of this parallelogram, right? So you have this, right? So I just arbitrarily just name 1, 2, 3, 4. It really doesn't matter as long as you're consistent, right? So you will find that the 1 and 2 have the same length. Yeah, so my graph sucks, but basically if there's a perfect parallelogram, this side and this side should be the same, right? So 1, 2, and 4, 3 should be the same length, right? The order doesn't really matter so much, but I would just keep it simple and put it in the right order, because length doesn't matter, but vertices will be slightly different if you put it in the opposite direction, right? So make sure it's the same direction for your insanity's sake. And then same thing, so 2, 3 is going to be same thing as 1 and 4. So if I calculate one, I know the other one, right? So why do both, right? So all I did was, so remember when we have points, right? It's always final minus initial, just like in physics, right? So P2 is going to be 4, 4, so 4, 4, and subtract them with 0.1, so which is 1, 2. So if you do that, I have 3, 2, and the same thing if I do that is 3, 1, right? For P2 and 3. So final minus initial. So final minus initial, right? So I have that, this, which is great. But here's the problem with this, though. I have these are 2 dimensions, which is actually fine because it's a vector, it's a line, right? The problem is, in order to find the area, right? Think of it common sense. In order to have an area, you need to have a plane, right? So because if I have this and I have another one like that, this gives me a plane, right? In order to have a plane, can only exist in 3 dimensions, IR3, right? So in order to do that, I need to make sure I have 3 dimensions, 3, 2, and 0. Just an unfortunate consequence. If I wasn't looking for area, if I was looking for a line, then yes, we can use these, but we can't if it's a plane. If it's plane, by default, that means it's 3-dimensional, so I need x, y, z coordinates. That's why, so we know 3, 2, we know 3, 1, we don't know the other one, so we just stick it as 0, because it was never mentioned. If the number existed, we would have seen some numbers, but we haven't seen the numbers. So that's what we're going with. Which just sort of makes sense. All these points, they must have a z-coordinate of 0, but nonetheless. So I convert this to 3, 2, 0, 3, 1 becomes 3, 1, 0. Trivial things, but important nonetheless. So remember the equation, area equals to the norm of the cross product of these 2 vectors. So, just make sure you don't use the same one. Make sure you use the 2 different ones, right? So I just do that. We do cross product a lot of times. So I get this. And then basically we have to just remember to do the norm. If we do the norm, square root of 9 is 3. Done. So pretty easy stuff. So 10 and 12, I wouldn't really worry about. Questions are pretty much exactly the same, just different numbers. So if you had some confusion, do it over, but I don't think it's worth it, to be honest. So moving on to question 13. Okay, so this is question 13. Again, 13 and 14 are pretty much the same thing, just using different points. There's nothing new or not new, so I wouldn't really bother. Just make sure you get the 13 right. Do 14 if you'd like, but yeah, it's I don't think it's worth the time. So anyways, go on to question 13. So we're essentially doing the exact same thing as the earlier question 11. The only difference is now is that the area is now a triangle. So if you remember what I mentioned, it's the same thing but divided by 2, right? Because that's the area of the triangle is base times height divided by 2, right? So anyway, so that's essentially what I'm doing. You actually, you don't have to worry about this part, but I'll show you why I did that, right? So nonetheless, so I have A, B, and AC. Don't worry about BC and BA for now. Just go with those. The important thing is, if you're choosing AB, you better be choosing AC, right? So, for example, as I've drawn here, if it's AB and AC, that will create a triangle. So don't mix it up with other things, right? So, now if I was to choose B, then it will be BA, BC, right? Or if I choose C, then CB, CA, right? But don't mix them up, right? Just make sure you choose one point and stick by it. So if I use A, B, and AC as suggested on the solution manual, then your center is A, right? So be consistent. So AB is going to be, same drill here. We're going to make it into 3-dimensional because we're looking for area. Same drill here. So just like what we did, the cross product of AB and AC, and then norm it. So yeah, essentially. Oh yeah, make sure norm stays on the top, not at the bottom, right? Divide by 2 should be what's done at the very end, right? So, wait, hold on a sec. Yeah, okay, so yeah, essentially, yeah. So, make sure norm it, norm first, divide 2 at the very end, right? So then you do that, and then you're gonna add 0, 0, 14, 14, right? Now, because you've, technically speaking, we should be doing this for consistency. So 2, that will be 7, right? Here, yeah, so that's that. So so that's how you really get it. Now, I just wanted to make another point by saying it really doesn't have to be A, B, and AC. Some people might be worried, how do you know which vector to choose? It doesn't matter, as long as you're consistent relative to where the center is. So to make that point, I'm gonna choose B instead of A, right? So if it's B, then it's BA and BC, right? So I have BC here, and then BA I have right there, right? So I'm gonna actually use these points. So assuming that, okay. Just to make it 3-dimensional. So if that's the case, then I just did that, and then basically, yeah, okay. So divide by 2. This is so annoying. 2, this whole thing divide by 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 2 gives me 7. Okay. So, but basically that's the idea. And I'm not going to do the C, but I'd imagine it will give you the same result anyway. So, it will always give you the same answer. So, when you solve a question like this, don't worry about where you're starting from. Just make sure you choose one point and then be consistent about it. That's all there is to it, right? So, 13, 14 is done. We're going to now do question 15. Okay, so second last question that I'm going to be dealing with are, depending on how hard 17 is, I may do 18 as well, but nonetheless. So 16, again, not necessary, just for the same reason as mentioned previously. So 15 looks a little weird, but ultimately it's the same thing, right? Ultimately, still finding a triangle, except the points are now 3-dimensional. Big deal. It's the same idea, right? So we have 3 points, so I'm gonna make 2. So I'm gonna make the center P1. So I'm gonna use P1, P2, P1, P3. You know, exact same thing. We don't have to make it 3-dimensional anymore because the points are already 3-dimensional. Same idea. So area is a triangle, so divide by 2, right? So, you know, just same drill that we did before. Yeah. So again, nothing too big deal, right? So, don't be intimidated. These should be like easy. So, I'd imagine we'll see this on a test and everyone should be just, flying their pens over there, right? So, it should be no problem. Question 17 is what we're going to do next. Okay, so another question. So, I might do 18 just because there's a bit of a determinant calculation that you need to go through again. So, but again, it's the same idea though. I would have skipped it if the question wasn't complex. But nonetheless, so we have 3 vectors and basically they are asking for the volume of the parapipette, right? So if that's the case, then so there's 2 formulas that you should be familiar with. This one, obviously, we're looking for this guy because there's U, V, and W. But you may get a question where it's just U and V. So if it's U and V, sort of similar to how we found the area, right? So it's going to be determinant of, so if I have U and V, then it's going to be determinant of U1, U2, V1, V2. Technically, there's U3 and V3, but like it will probably be 0, just like what we said, right? So for example, if U was 1, 1 and V was 2, 2, right? Then it's going to be 1, 1, 0, 2, 2, 0, right? So that's the idea, right? And that makes sense because, 2, because it's a plane. The plane is, so it's because it's 2-dimensional, it's going to be a plane, is going to be a line, so that makes, oh yeah, we still have to find the area, so technically this is still a 3, my bad. Right, that's why you added the zeros, right, to make sure the area is plane, right? So, good. Now, the other one, basically, same idea, if we have 3 vectors, then it's going to be multi-dimensional, so 3D, right? So so because of that, so oh yeah, that's why we don't say it's an area anymore. So we say this is volume. Whoops. Right? Because think about it, right? So if using two vectors to find a plane, right? So if I have a vector here and vector here, that will give me a plane equation, which is 3D area, right? But if I have 3, what would that give you? That would give me area. So volume, right? Because it's like area 3D, right? So that's that. So basically, this is what you have to do. Just make sure this whole thing is an absolute value. Please don't forget that, right? In quiz 3, some of the people forgot to mention absolute value. So try not to make trivial mistakes like that. Then just go from there. Determine and bum. And yeah, so we already know how to determine. I just got rid of the third one just to make my life easier. 0, 0. Then that way, all I have to do is just finally determine this. Rest will be just cancelled out by 0. So I got negative 16, but again, it's absolute value, so it's going to be 16. So that's all there is. I'll just flash at you question 18 just in case, but honestly, I wouldn't really... Yeah, I'll do 18. But yeah, honestly, I wouldn't really worry about it. So, moving on to 18. So, this is question 18. So, just, same concept, so I'm not going to explain it again. Just flashing at the answer, so just take a look. And it gives you an area of 45, just so that you're comfortable finding 3 by 3 determinants, if you were if that skill has become a little rusty. So, nice review. But honestly, that's all there is. So, pretty simple, right? So, we will eventually get to 4.9 and 4.10. So, hopefully we can get that all done, and then we'll be ready for the quiz next week. Oh, well, maybe 5 too. I'm not sure if 5 is on the quiz, but we'll find out. I hope to upload it eventually. So, anyways, that covers 3.5 cross products. So, yeah, I'll see you guys back in 4.9.